dealing with HB of 133 kV AC and 150 kV DV SC of 30 kA DC, HP of 5 megawatt at an individual equipment level. He has worked with various companies like Reliance Industries, Fusey Electric, Hind Rectifier, Adol Powerton, Resume, RPG, etc. With this, I request our expert Ajit Kothari sir to kindly enlighten us with this word of wisdom. Sir, you can start. Sir, please.
Thank you, madam, for nice introduction. So with this, we'll straight away we'll start with our today's session. So I'll first share my screen here. Hope my screen is visible to all. So this today's session is on the integration of green energy with electrical vehicle charging station. So last week we had this session. But before starting, I just wanted to know, or I came to know from Simanta that this today's audience is not the same. Maybe 40, 50% are new. So I would like to start from beginning. So earlier we discussed on the BMS part as well before this session. But now, since today's session is on the integration of green energy with electrical vehicle charging, I'll straight away start with electrical vehicle, and maybe on Friday we'll go in detail with BMS. Uh, Actually, I wanted to start with BMS so that the link will be maintained. But since it was scheduled on Friday, I'll go with BMS on Friday. Yeah. So we all aware about the electrical vehicle. So it is just a technical, the definition of electrical vehicle here. So it is nothing but a vehicle which powered entirely or partially by electricity instead of traditional internal combustion engine, which uses the gasoline like diesel or petrol or CNG, where EV uses the traditional battery storage system, where electrical energy is stored and that is used for driving the vehicle. So this is what we know about the EV. So we will go in detail before we jump to this integration of charging station or renewable energy with the this charging station. So we should know about what is EV first, and then we will have brush up on the charging station requirement, and then we will go with the integration of renewable energy with this setup. So as we know now this what is electrical vehicle. So here we try to elaborate more on the EV vehicle, types of EV vehicle. There are 4 different types of EV vehicle. Out of that, most of us know only about the battery EV vehicle, and another is the hybrid vehicle, which is more popular, or we can say Maruti Suzuki in India has launched the hybrid vehicle initially. Now they are going into EV vehicle. So the battery electrical vehicle, which we generally seen in India, is the vehicle which is powered only by batteries, rechargeable batteries. So the more the advantage of this vehicle is zero tailpipe emission, Example, it was US example I mentioned, but now in India also we have a lot of EV vehicles available. For example, Tata Tigor, Tiago, Punch. Then Hyundai is also coming up with EV vehicles. Now Maruti has also announced they are coming up with EV vehicle. So this section or this what you call the field is I mean the whatever developments are happening into Indian vehicle industry is in EV or the hybrid vehicle. Second is the plug-in hybrid electric vehicle. So here it is kind of a vehicle which has battery as well as the gasoline or the our common whatever uh, engine we are having, the IC engine we are calling it. So it works on the electrical motor as well as having traditional combustion engine which works on petrol or CNG. But the catch here is the whatever battery is there inside. It is not similar to your EV because EV works 100% on battery. But this batteries capacities are very less compared to the EV vehicle, and these batteries sizing is meant to means travel for a lesser distance, you can say. So, and these are not charged themselves by the vehicle. You need additional or external charging system to charge these vehicles. So these are not like hybrid vehicles. This hybrid vehicle, you must be knowing about this. So these are similar to the what we saw, this plug-in type of hybrid electric vehicle. So these are similar to this, but here charging is not required for the batteries. So batteries are getting charged with the charger, inbuilt charger inside, which is regenerative type of charger, which generates the electricity whenever braking is happening or whenever vehicle is in a moving condition. So that energy is again converted into the electrical energy to charge the batteries, and that battery power can be used whenever the vehicle is standing or maybe idle condition, when where more energy is not required but fuel is getting consumed. So that time battery power is utilized, and you are saving on the fuel. So the efficiency, or you can say the mileage what we are getting in this uh, our normal vehicle with petrol is almost double because of the battery. So whatever power is getting wasted, that actually in hybrid it is getting converted into electrical energy, and that energy is stored in the battery, and that battery power is used for vehicle driving in some cases, and in some cases it is used to run the accessories of the vehicle whenever your vehicle is in the idle condition. So it will save on the fuel indirectly. The fourth type of vehicle is the fuel cell electric vehicle. Now these are mostly the hydrogen fuel cells. In India, now this commercialization is not yet fully started, but Reliance has already made some truck vehicles using these cells with the help of Ashok Leyland. So they have developed the engine for this, and hydrogen is already available or manufactured in Reliance refineries, and they are using that hydrogen to fuel these trucks. So these are on a trial basis. They are running these trucks for their inside use and for shorter distance. So maybe after a year of the trial testing, they will start the commercialization of that trucks. Initially, it will be used for the capex purpose or their own use, and then maybe it will get commercialized for the other people as well. So these are the four basic types of EV. So since our topic is to integrate renewable energy to the power charging station of EV, so for us, the first type of vehicle is important. So we'll focus on the electrical vehicle, which is 100% battery, uh, uh, I mean, battery vehicles. Okay. So inside of EV, if you see the block diagram, here I tried to mention only the major blocks of EV related to electrical engineering, not the mechanical. So here the major component or important component is the battery pack. So this is battery pack. Then this battery pack is storing the DC voltage, as we know. This DC is getting converted into AC by DC to AC converter, and then AC motor is used to drive the vehicle. So these three are the important, can say the blocks of the EV. Apart from this, you need some electronic circuit inside or power electronics, which is used to drive the DC load. For example, your whatever AC is there inside, some lightings are there, your dashboard, your maybe your music system. So all these works on DC load. So and requires very low voltage. So that low voltage is generated by this DC-DC converter, which is using again this high voltage battery DC voltage, and it is reducing or stepping down this DC to use your DC load of your vehicle. Another important part is your AC to DC converter. So to charge these batteries, we need a rectifier. So this is onboard rectifier, which works on the AC input. So input AC is generally from our utility. It is connected this three-phase AC to this AC to DC converter. This is onboard charger, and this is charging the batteries. So these are the major blocks, you can say, inside the vehicle. And out of that, these three are the major blocks which are common in all the EVs. And this onboard charger, DC-DC, it depends on vehicle to vehicle. Again, the battery pack, whatever there inside the EV, it again depends on the OEM. So what kind of motor they are using, what is capacity of that motor. So depending on that, they are deciding on the battery pack voltage and the capacity. And this capacity again depends on the mileage what OEM is expecting from this vehicle. Let's say if they are designing this vehicle to run on a single charge of, let's say, 200 kilometer or 250 kilometer, they are designing or selecting the batteries accordingly. If in future maybe if they want to increase the mileage, then they have to either increase the capacity of this battery pack or reduce the capacity of their vehicle loading capacity, or the what you call the kilowatt of that motor. But that will reduce the overall what you call the capacity of vehicle to take the load. Maybe from SUV to they will come out with some hatchback or small car where smaller motor will drive. So with the same capacity, they can have the more mileage out of that vehicle. Right? Okay, so we have already seen the major blocks inside the vehicle. Now we will just see what is their function of each block. So battery packs, they are storing the electrical energy to power the motor, and commonly used in India now the lithium-ion batteries. So earlier there was, I think, one or two vehicle in India, maybe 4 or 5 years back, when they use the lead acid batteries to drive the motor. Even some three-wheeler rickshaws are also available in north side. where they are still using the lead acid batteries. Now, for EV, almost 90% now it is with the lithium ion batteries. Second major component or key component is the electrical motor. So electrical motor, as you know, this is major driving force to drive your motor, your vehicle on the road. So generally, this is AC kind of AC motors only they are using. But some vehicles earlier in old days, they were using the DC motors just to avoid this electronic part at that time, because the development of AC to DC converter was not uh, up to that mark earlier, because they were using the analog circuits, and means high frequency circuits were not there that time. So the size of AC to DC or DC to AC converter was bigger. Then they use the DC motor, simple DC motor. But now, since electronic is advanced, and we can reduce that, what you call the DC to AC converter sizing, and it is transformer-less now, converters are available. So that is reducing the weight of that converter as well. So, yeah, and as you know, these AC motors are more efficient than DC motors. The maintenance cost of AC motor is also very less. So now maximum OEMs are using AC motors into the vehicle. Third part is the power electronics. So as we saw this, all these DC circuits of your vehicle is working at low voltage DC. So this general battery sizing or battery voltage of any vehicle or four-wheeler vehicle is around, it starts from 200 volt, minimum 200 volt DC, and goes up to, I think, 400, 450 volt DC. Again, depends on the OEM and type of vehicle they are using. So to have, means the vehicle is having the battery pack of 200, minimum 200 volt. So to make it 12 volt or 24 volt, this power electronic circuit is there, which is converting this high voltage DC to low voltage DC. Another is the onboard charger. Already we saw. So this is simply it is a rectifier unit, which is, you can say, the charger required for this charging the batteries of the vehicle. So this is in onboard charger or small capacity charger of around 10 to 20% of the battery. It is available inside the vehicle itself, so that you can just connect the AC supply with a nominal 15 ampere minimum power. That will take almost 6 to 8 hours to charge the batteries. So this is slow charger, you can say. Then other important things are the regenerative braking system, where this power is whatever mechanical inertia or the power is there, which is getting converted into electrical energy, and that is again fed back to the batteries for storing that energy. Then thermal management system. This is again an important system into the electrical vehicle or battery, where different sensors are used. So a lot of sensors are there in the battery pack itself, which are sensing the cell voltage. Then there are other electronic component as well in the vehicle. Like DC-DC converter is there, DC to AC converter is there. So power MOSFET or IGBTs are used into that power circuit. So their thermal temperature, or you can say the heat sink temperature, is also measured, and that temperature is used for, you can say, the switching off of the vehicle in case of it is exceeding the temperature. So it is like a protection for your vehicle. So before something happens, it will stop your vehicle from running into the trouble. So these are the major key components of EV. Now, advantage again, we know what are the advantage of EV vehicle compared to your IC vehicle, what we are using generally. So the major benefit is the zero emission or what you call zero pollution by the uh, vehicle. Then the second is the noise pollution is also you can say very less. It is not generating the noise what is produced in the normal our IC vehicle because of a limited you can say the mechanical inside the vehicle. Then the lower operating cost. So operating cost in the sense the fuel consumption or fuel cost of our petrol vehicle or CNG vehicle is very high. If you see the means cost of that vehicle, it takes almost I think uh, the 5 to 10 rupees in the range of 5 to 10 rupees per kilometer is the fuel consumption cost of our major four-wheeler vehicle because the mileage given by the vehicle is almost 10 to 15 kilometer per liter in the city. So it is minimum it is I means maximum it is 10 rupees and the efficient vehicle if you have which is giving the 20-25 kilometer running, it will come down to 3 or 4 rupees but not less than that. But in case of EV, your charging of any vehicle will give you almost 200 kilometer of range, and the cost of charging of that battery is around 200 rupees. So 1 rupee, less than 1 rupee per kilometer is the efficiency cost what we are getting right now. But in future, again, it is going to get reduced further. So it is almost 3 to 4 times saving is there now if you compare today's price. Since moving parts are also less, your maintenance cost again will come down. So the maintenance is only the battery. So battery actually doesn't require any maintenance, but maybe the replacement after 4 or 5 years of uses of your EV, because the it again depends on how much you're using your vehicle. So the general life of lithium ion batteries is around 10 to 15 years. And if you compare with the cycle, so number of cycle means how many times you charge and discharge the batteries. So that cycle, number of cycles are almost in the range of 6,000 to 10,000 of that lifespan of that batteries. So 6,000 means even if you are charging, let's say once in a day, every day if you are charging or your means your driving is almost 200 kilometers in a day, and you need one complete cycle of charge and discharge in a day. So 365 will be your cycles per year. So you can see this maybe 10 to 20 years is the lifespan of that battery if you charge with this speed. So going forward, the issue with battery is whatever efficiency you are getting today or with the new battery will not be same maybe after 2 or 3 years of that operation of that batteries. The deterioration or degradation of battery is almost in the range of 3 to 5% every year. So if you are getting, let's say, 200 kilometer of range today, when your vehicle is new, maybe after 3 years, it will get reduced by another 3-4%. So almost it is in the range of 190 kilometer. Then after every year, it will get reduced by 2 to 3%. So every year, you will get the mileage reduced by 4 to 5 kilometers. So that is the only disadvantage right now in the lithium-ion battery because of the degradation of batteries. But the lifespan of battery is still it is very high. If you compare, the vehicle life is almost 15 years in India, we are saying, but still we are using it for 20, 25 years. But now, because of these batteries, if your limited uses are there, then you can use these batteries for 10 to 15 years. Whatever manufacturers are claiming right now in India is 5 years guarantee now, maximum they are giving because of the harsh condition, the weather condition, or how we are driving. So because of that only they have reduced it to 5 years. But going forward, I am sure it will increase, maybe 7 years, 8 years, seeing the performance of batteries. They will try to improve the guarantee of batteries. They already now touch 5 years. Then we have the government incentives as well. So government is promoting these EV vehicles in India, and they are giving the incentives in the form of tax credits, subsidies to the OEMs and to the end user as well. So that it gets reduced, the price gets reduced by substantial amount. So these are the some major advantage of EVs. Disadvantage, I told you, only thing is the degradation, but again, it is not impacting as much as what we are thinking. Going forward, again, technology will improve and the life of batteries again will increase, and we will get the more efficient batteries in future. So some the development work is still going on the solid state batteries. So I hope maybe within next 2 to 3 years span, we'll get some better efficient batteries, which are means hazardous wise also it is safer to use that vehicles in our vehicle. Now we'll come to the charging of that vehicles. So now we understood the EV vehicle, what is there inside, what is the advantage of EV, what are the key components in the EV. So our focus is mostly on the battery pack. So to charge this battery pack, we need a charger, outside charger. Onboard charger is already there, which is taking more time to charge the battery because of the lower size of onboard charger inside the vehicle. So it is of the capacity, you can say in the range of 3 to 5 kilowatt. So if your battery capacity is, let's say, 50 kilowatt and your charger capacity is 5 kilowatt, so almost it will take 10 hours to charge the battery. I am not considering any losses here. Just the ideal condition, it will take minimum 10 hours to charge the battery from 0 to 100%. So you can imagine what kind of power it is taking, how much time it is taking to charge the batteries. Now we have come out with some solution to relieve our what you call the user who don't want to use or wait for getting charged these batteries, because the initially when these EV vehicles designed or it is launched, they thought that we will use it in the daytime and whenever we are at home, our vehicle will get charged. So that was the initial concept. But now, after the uses, or you can say um, the uses of EV has increased. Now people don't want to wait. Even the taxis are also working on this EV. So they don't have any waiting time. So 24 by 7, they want to run their vehicle. Maybe 2, 3 hours or 4 hours of rest, hardly they are giving to their vehicle. And they are having multiple drivers to run that vehicle. Even in transport also, when we start using these batteries for our truck, which is used for transportation, or even in case of buses, they are running 24 by 7. So they have multiple drivers to run the bus for 24 by 7. But what about the charging? What about the battery charging? So if it is taking time, then there is no what you call the improvement in this segment. So that's the reason this fast charger have now come out with some solution. Still, some more work has to happen in that area, because batteries are available, but we don't have the infrastructure to charge the batteries at very high rate. So you can imagine, if it is 50 kilowatt hour battery pack is there inside the battery, and if I want to charge that battery, let's say in hypothetically 15 minutes. So 15 minutes is also very high if you think of European and other countries. So they don't want to wait. It is like petrol only. So going to petrol station, filling the fuel, and going. So that concept they want now in EV. But even if I take 15 minutes to charge the battery of 15 kilowatt hour, I need almost 200 kilowatt of power to charge the batteries. So, and going forward, these battery capacities are also going to increase, which will again demand more power for charging the batteries at for the fast charging station. So in future, the requirement of power will be very huge, because you need to charge all your vehicle at very high rate. The C rates are almost at the rate of minimum 4C. 4C means 4 times the capacity of that battery pack. So at that rate, if you want to charge your batteries, then again it is taking 15 minutes. So you can imagine, if you want to increase the C rate, your time is going to get reduced. But the major challenge is to have the high power station to supply that high power to your batteries. So that is the challenge in this field actually. So the EV charging basics are like electrical energy is required. That is the major component. And that AC is again converted into DC, so that your batteries are getting the required voltage and required current, so that it will get charged. Now there are different types of chargings available for the EV. The first is the slow charger, which is generally it is either it is onboard charger, or a separate charger is supplied in case of two-wheeler. Separate charger is given along with the vehicle, so that you can carry that charger with your vehicle or keep it at home, and whenever you want to charge, you can just connect that DC power to your vehicle, and take AC power from your residence or office supply, which is generally of the range of 240 volt, or in case of means generally it is single phase supply only. This is slow charger, and the capacity is of the range of 1 kilowatt. So maximum 4-5 ampere it will take from your utility side, socket. Since the power of this charger is very low, it is taking almost the charging of 10%. The charging rate of your battery is 10% per hour. So almost 10 hours are required to charge your batteries. Second is the level 2 charging, where it is little bit fast charger compared to your level 1 charging. Here it is either a single phase supply 240 or 415 volt in some cases also can be used. But the socket capacity is in the range of 15 ampere. So with this power availability, your charging rate gets increased from 10 to 20% minimum. So 20 to 40, in the range of 20 to 40% per hour, your batteries are getting charged. So it will take almost 5 hours minimum, sorry, maximum, and minimum it will be 2.5 or 3 hours. It will get charged your batteries. So this is level 2 charging, which is again a AC supply is required, which is in the range of let's say 5 to 10 kilowatt, which is available in most of the societies, in the common areas or in your office place, workplace. That power is available. So from there, these chargers are getting connected. Third is the DC fast charging. So this is the area which we want to focus now, because earlier level 1, level 2 are available AC source generally in everywhere in India. So we are depending on that, but the disadvantage is it is taking more time to charge your batteries. Now the charging station, what we are talking now, is having a DC fast charging facility. So it will take more. It requires a big, I mean, huge power from the utility, and it will draw more power, and it will charge your batteries at a faster rate. So generally, now whatever charging we are having in India, they are charging at maximum 20 to 30 minutes it will take. But the catch here is we are not charging our batteries from 0 to 100%, because some power reservoir is always there in the vehicle. So at 10% we are cutting off the vehicle batteries. So the charging is required from 10 to 90%. So this is, if you see the characteristics of lithium ion batteries, the curve of charge is almost horizontal line from this 10 to 90% of charge or SOC of that battery. And when it reaches 90, from 90 to 100%, it takes more power or more time, because it is charging at a very slow rate. You cannot fast charge the batteries once it reaches 90% of charging. So just to avoid that, the whatever fast chargers are available, they will charge your batteries up to 90% only, just to avoid the what you call the charging time. So that's the reason we are getting our batteries charged up to 90% level within 20 to 30 minutes. Okay. Now the we'll just see the charging processes as well. How these vehicles are getting charged, what are the components or different what you call protocols of communication and other are involved in into this. So the first and most important thing is the connection. So connection, when we are saying connection, connectors are very important. So connectors are already available on the vehicle. So you have to just connect the vehicle or whatever charger you want to connect with the suitable connector. Now in India or everywhere now in the world, they have come out with some standards of connectors. So even though their batteries are not standard, at least they made the connectors standard now. So type 1, type 2 are the connectors which are generally required for the onboard charger. So these are AC terminals. And then CCS and CHAdeMO is there, which generally required for the fast charging purpose. So these are DC connectors. So these four connectors are standardized now, and most of our charging stations are having this kind of connectors or the mating connectors at their charging end, so that you don't have to suffer for getting your vehicle charged. Right. So that's the reason now our mobiles are also having the standard charging terminals now, connectors. Earlier we had three, four other different type of connector. Now the C-type chargers or C-type terminals are there, so that you can use anybody's charger for your charging your mobile. Because the batteries, even though batteries are standard now, everybody is using lithium ion batteries of same voltage, maybe different capacity, but if you are changing the charger, it will not harm the battery of your mobile, because their voltage is same. So because of the different capacity, only your charging time will get changed if you change the charger. Otherwise, that is also not a problem going forward if you standardize on the battery size, but which is very difficult in mobile. Similarly, for the vehicles also, it is different. Now here the another challenge is we don't have the standard voltages. Everybody is having their own voltage. So the challenge from the charging point of view, their range requirement is very wide. So from, let's say, to charge, let's say, a battery of 200 volt, at the same time, let's say 600 volt battery is also they want to charge with the same charger. So the charger size, or you can say the output of charger, should be suitable to charge any battery from the range of 200 to 600 volt. That is first charging the challenge. Second is the capacity of battery. So again, it depends on which capacity of battery is used in the vehicle, whether it is 50 kilowatt, 60 kilowatt, 30 kilowatt, 100 kilowatt. Now we have the varieties right from 30 kilowatt to 100 kilowatt in the four-wheeler now, four-wheeler segment itself. So your charger should be suitable to charge all these batteries. So you cannot say that your charger is not able to charge the 100 kilowatt hour battery. So maybe the speed will vary, but at the same time it should charge all the vehicles. So that's the reason a government has come out with this standard connector, so that you don't have to face the challenge of different connectors as well. So capacity wise, yes, the charger capacity should be wide, let's say from 200 to 600 volt at present. Maybe going forward, if trucks are also coming with their own different voltages, then again it will be the challenge for the battery charger, or the station point of view, I am saying. So right now we don't have any challenge, because now this industry is also standardized their charger, which are suitable now for our present setup. And I hope going forward, OEMs also will think of this limitation of charging, and they will design the vehicle with the battery band of this voltage only. That is 200 to 600 volt, what I am saying. So connector is there, important thing. Second is the communication. So communication, when I say it is important from the charging point of view. So the battery should communicate with the charger on the capacity of that battery pack. So it should give the information to the charger or charging station about the requirement of charging of that battery, particular battery, because all batteries are different capacity, different voltages, as I said. So how the charger will come to know at what voltage, at what current it should charge that battery. So this handshaking or that information, exchange of information is happening through this communication initially, and then only charging of that vehicle starts. So communication is again a very important role. So here again the communication language, at what protocol our BMS or the battery is communicating with the charger, that is also standardized now. So we have standard connectors, we have standard protocols for communication of that information with the charger. So we don't have any challenge in deciding what charging is required, or the parameters required by the charger. Then the charging initiation. So once this communication happens, the charging starts. Then the charging control. So as I said, BMS is there to prevent from overcharging or overheating of the batteries. So BMS is inbuilt with the battery pack itself. So that is inherent, or you can say the internal part of that every battery pack. Without that, nobody is selling the batteries. So BMS is very important part, which is inbuilt into the battery, and it is controlling the or preventing the batteries from overcharging and overheating of that batteries. So this is the main component which is giving the communication to the charger, at what rate it should charge the batteries. Then fifth is the completion. So once the charging is done or completed, charger should stop the charging. So that again, and user should know whether his batteries are getting charged or not. So that communication or that indication is also given to the user, so that he stops the charging of your vehicle. So these are the steps which are generally required at the charging stations. Now, if you have might saw this charging station, these are the general picture of our charging station. This is charging station or charger disconnected through this fast DC cable to your vehicle. And this is the picture of that charger, where AC and DC both terminals are available. So whenever you want to charge, let's say this charger is not suitable for your battery. That is, I'm saying hypothetical condition. Let's say it is not getting charged with your battery, then this additional source is also available. You can charge at a slower rate with this AC supply as well. So that is also provision is available in the charger. But now we don't have that problem now with the DC connector, whatever is available. So earlier we supplied with both the connectors. Now only DC connectors generally are available. But in case of emergency, we are still giving the AC cable also, or AC connector also, to the charger, so that in case of emergency you can still use your charging station for charging the vehicle, because the power connected is very high. So same power is connected to your vehicle, so that you can charge at maybe faster rate. So this is the general what you call the infrastructure required for your vehicle charging. So this general AC grid is available. This I'm showing about the charging station only. So maybe high voltage grid or 415 volt grid is available of high power. And your charger is consisting of this three blocks: DC-DC converter, AC to DC converter, and the filter. So because these chargers are generating huge harmonics here, so to suppress that harmonics, filters are generally connected at the input of the AC source, so that whatever harmonics are generated here should not interfere with AC supply, or they should not pollute our AC supply, which is used for our domestic purpose. So this is the reason filters are used. Then this AC is getting converted into DC first, and this DC-DC converter is there, which is controlling this battery. And this is required because here we want variable DC output, DC current. That's the reason this DC-DC converter is connected at this stage. Otherwise, in normal condition, this AC to DC converter is sufficient to charge our battery. So if you see the block diagram of our onboard charger, it is just a AC to DC converter, because that onboard charger has to charge only the fixed kind of battery. So it is designed for that particular battery only. But here, this DC-DC converter is suitable to charge any type of vehicle which is manufactured in India right now. So these chargers are suitable to charge all the four-wheeler at present, all the four-wheeler vehicle for this charging purpose. Right. So this control system is, of course, it is required to control the voltage. Then the communication is also required to understand the signal sent by this BMS to this charging station. And then once charging is completed, it should give some alarm or some indication to the operator as well that yes, charging is completed. So all these electronics are also involved into the charging station. So this is the major component of infrastructure or requirement of the EV charging station. So now this what shown here is for a particular one vehicle. But going forward now, when we are talking about the charging station, it may not be a single charging station or two charging station in a charging outlet in one charging station. Maybe there are multiple outlet like we have for the fuel. So we have multiple terminal for fueling our vehicle. So going forward in future, maybe we'll be having a dedicated charging station where 10 vehicle or 20 vehicles can be charged at a single time. So if you think from that point of view, your infrastructure, the challenges to feed the high power to that particular charging station will be very high. So the picture here or the block diagram here shown is only for single charger. Now we will discuss on the requirement for the you can say the power or the charging station where multiple outlets are there. So it starts from the site selection, because if you want to install, let's say 10 or 20 outlet, you need a bigger space where at a time 20 25 signal vehicles are standing with the charger for let's say 15 or 20 minutes of that time. And for this 20 minutes, again, same similar vehicles may be in the waiting also. So you need a very big space to accommodate all the vehicle. These I am telling from the future point of view. Today we don't have that requirement, but going forward, when your IC vehicles will get reduced and that place will be taken by this EV, then number of vehicles will be more. And the scenario what we can see today is, let's say 20 vehicles are standing and they are getting charged. Another 20-30 vehicles are there in queue which are waiting for that outlet to get I mean empty, so that that vehicle can come there. Again, it will take 10-15 minutes to get the charge. So that scenario, if you see this, ample of parking space is required. Ample space is required for accommodating that charging stations. Then electrical power supply is required, because if you have a 20 outlet and each outlet of let's say 20 kilowatt, then 20 outlet means you need almost 4 megawatt of power. to connect or to use that power station, or you can say the charging station. So huge power requirement will be there. Charging equipments are required. Communication, networking is also required, because all data, whatever power consumption is there, whatever losses are happening, or billing, whatever billing we are doing, it should be getting communicated, or somewhere or in server, some that information will be available. That particular vehicle is charged with this and that rate. So what should be the what you call the charging charges? So for all these, networking is also important. Then safety compliances is required, because you are handling such a big power in that particular area. It is as good as your fuel tank or the petrol pump. The safety, whatever you are taking care there, here it is in terms of power requirement. So safety is there from the power point of view requirement. Then installation requirement, energy management is again a big challenge going forward. So maintenance of all these whatever equipments we are going to install, scalability is also will be the big challenge, because if your vehicles or type of vehicles are different, maybe tomorrow, uh, now we are talking about this hatchback and SUVs. Maybe buses will come with bigger space. So that scalability is again required. Trucks are coming, so we have to accommodate that truck also for charging. So the charging station is a big challenging, what you call uh, maybe the requirement in future when EVs are more. So these are some points I just noted down, where we can say that these are the challenging areas, or these are the things which we need to do maybe a detailed study to design the power station or the charging station. Then the renewable power is also required, because you cannot just depend on the utility power, because in city this high voltage line or this high power line may not be available, because already our cities are getting exhausted with whatever power is available. Now if you want more power, either you have to install your this what you call the charging station outside the city limit, or bring some renewable energy inside, generate the power from outside, take that power to your power station, which is you're planning to make it in city limit. So that power can be taken from this renewable, which can be maybe you can install that renewable power station outside the city limit, run that power line to your charging station, or your charging station itself is outside. You can have a complete bigger charging station with renewable resources also inbuilt. So these are some points which I just wanted to highlight here, because going forward, if you don't think just a single outlet or double outlet of your charging infrastructure, then you can think how much big requirement will be there for this infrastructure, to develop this infrastructure. And this may not be a single or one or two power station or charging station inside the city. Maybe you need uh, uh, the number same as good as the petrol pump, whatever you have minimum. That should be your requirement going forward. So that many outlets are required, right? Uh, these are some general pictures, or you might have seen in some office area, workplace, where the solar systems are connected. They are generating some power. Either it is getting stored in some battery energy system, or it is directly connected to your vehicle. So some companies are providing this facility to their employees to charge their vehicle. And the solar panels are, they uh, are doing the double purpose. It is providing the shade to your vehicle, as well as getting power from solar and charging your vehicle also. So these are the pictures for smaller capacity, you can say. A smaller charger is available, and maybe your if your office is of 6 to 8 hours, your vehicle will get charged in that period, or multiple vehicles can be charged. Maybe if you have three charging station and 6 vehicle, so maybe in first half 3 vehicles will get charged. In second half, another 3 can be charged. So these are the way we can do the charging at the workplace also. So this is the general practice now adopted by major of or more by our workplace like IT industries and other. They are already having these facilities for their employees. Now, if we think of requirement of high power for the charging station, then now we are thinking of how to use that renewable energy for this EV or charging station. Then EV can be, this renewable energy can be from the solar, from wind, and you cannot just depend on the renewable energy itself. You need some battery storage unit also, where whenever these renewable sources are available, that energy whatever is generated shall be stored in some form, so that whenever it is required can be used, because renewable energy sources are not constant power supplier. If you see the solar, they will give power only for 6 to 8 hours. And that again depends or varies according to your season. If it is rainy season, it will give lesser power. If it is summer, it will give you more power. Winter, moderate power. So it depends on weather as well as the wind. If you are thinking of wind energy to be utilized, then wind is also not the fixed kind of power generator. That again depends on how much wind is flowing. So then only power is available. That time only power is available. So this is unpredictable power generation, you can say. So to make it reliable, you need a battery energy storage system where these energies are getting stored whenever it is generated, and can be used whenever it is required. So if you want to integrate your renewable energy sources to this power station, you have to have this battery storage also available, so that it is taking power from your renewable as well as from energy this grid. That energy is stored here, and this energy can be used to charge your vehicles. Whenever vehicles are there, these vehicles will get charged with this energy from the battery, because this is available with you always, because you have already stored this 100% batteries. So whenever power is there, either you charge your batteries, or if loads are available, loads in the sense here it is EV. So if your vehicle is available, you charge your vehicle. If vehicle is not there, you charge your batteries. So that is how this program can be done to charge your batteries or your EV. Now, going forward again, what I said, the requirement of the real charging station where 10 to 20 outlets are available. So there, you should have your own renewable resources, renewable energy generators in the form of PV or wind energy. So that is connected to the common DC bus. Again, utility grid is there, which is means again getting converted into DC, connected to this common DC bus. Then this is a battery storage unit where this is having the bidirectional converter, and through that the DC supply is connected to DC bus. So this DC is available, always available here. So whenever this is available, either it will charge your vehicle or it will charge your batteries, because this is bidirectional converter is already connected here. So whenever PV is available, it will charge. Or in case of PV is not there, utility is not there, this battery source will start giving power in other direction to your load. So this is how this renewable energy battery sources and this charging station will get integrated to each other, and the power can be transferred from one place to another place. Now here, if you have the bidirectional converter also here, so the power, let's say in case of emergency, these vehicles are having some power, and here you don't have any power. So to light up your maybe infrastructure, you can take this power back into your system and connect your maybe here another system where you can generate the emergency kind of power from these vehicles also, or you can charge your vehicle from one vehicle to another vehicle. Let's say one vehicle is standing here idle, nobody is there to take that vehicle after getting fully charged. You can transfer that energy back to another vehicle also, if you are having these bidirectional converters here. So that technology also people are working on it. So in case of your housing societies also, you can take that power and use that power from your vehicle to either your home or your society, or powering up in case of emergency. So that system is again under development. So going forward, this will be your maybe the overall infrastructure requirement when you think of a complete or dedicated charging station requirement, right? So these are some points again I have mentioned here. The earlier list was related to the overall requirement of what you call the charging station. Uh, these are, and since our topic is on the renewable energy, so we, or rather, I have focused more here how to integrate this renewable energy for this charging station. So here again, solar panel requirements will be there. Wind turbines you can use to generate the energy from renewable sources. Then ESS is required, because this whatever energy is generated, that has to be stored, because this is not a fixed kind of power we are getting from the renewable resources. It is variable kind of power. So we need to store all this power whenever it is available, or in idle condition, whenever power resources powers are generating, you should have the vehicle to charge for charging purpose. Otherwise, whatever power is generated by renewable resources, it is getting wasted. So that's the reason ESS is very important from that point of view. Then vehicle to grid, as I said, can be done, but this is again a part of development and not much required. But this can be a selling point from the OEM point of view, or whoever is manufacturing the charger. They can say, I can draw, I can charge your batteries, I can take your power from your batteries as well to use for your emergency kind of thing. So that is from the charger manufacturer's point of view. This can be their selling point of selling what you call the USP. Then the hybrid system. So hybrid system means we are connecting all the resources to one station, so that you can use the renewable resources 24/7. So if you consider all these three, like solar, wind, ESS, all these three will give you the 24/7 power for your maybe the charging station what you are thinking. In addition to this, whatever is available power, grid power, that can be also again connected, so that you should not feel, I've shown it red here, because the uses of this utility power should be the minimum. So you should not depend on this utility power. So whatever resources you are designing here, let's say solar or wind, whatever power station design you are doing, that should handle how many stations are available here, what is the power requirement of each station. So that much power should be generated by these renewable resources, and it should get stored into this. So the requirement of battery should be designed accordingly, so that it will give the power to charge all these vehicle in case of whenever they are coming in the night also, when renewable power is not getting generated. In case of solar, if it is not getting generated, your battery should supply, or wind power should be available, so that it should give power to your batteries to charge. So this is how we should integrate this hybrid system and get rid of the shortage of power to charge our vehicles. So these are some what you call the charging systems required for the renewable energy. So some these are some challenging, I can say some challenges I have put up here, because if you want to handle a very high power in the megawatt I mean range, you have to have a good load management system where your load is not fixed, because vehicles are keep coming, they are connecting, disconnecting. A lot of vehicles will be charged at a time, maybe disconnected at the same time. So dynamic load management system should be there to handle all this kind of power required for that infrastructure. Then time of use should be optimized. So we should have the charger smart enough to charge your vehicle at a very fast rate, so that how to means you can utilize your maybe airport timing here, because if you see the planes are coming, they are dropping the passengers and immediately they are taking the new passenger to fly for the new ride. So the time management what they are optimizing at airport, similar kind of time optimization is again required at the charging station also, because you cannot keep your vehicles waiting for getting it charged. So your waiting time should be zero if you are talking on the ideal point of view. So whatever time I am spending to charge my vehicle at maybe power station should be the charging time only. So if my batteries are getting charged within 10 minutes, I should spend only 10 minutes or 1 minute extra for my billing. So that should be the ideal condition, the way I should handle or optimize my time at the charging station. So that going forward, that will be the big challenge for the operators. Then AI should be there, IoT. These are some supporting, you can say, for the charging station, because if operators are not there, maybe the user himself can charge his vehicle, connect the charging point to his vehicle, charge it, pay it, and leave it. So if you want to make your charging station maybe the operator free or man free, you should have all these help from the electronic system as well. so that it can be charged by the owner itself, the vehicle owner itself. Then grid integration is again required, because if you are using your renewable resources here, then all these renewable resources, whatever energy they are producing, should be integrated with the grid also, because it should be synchronized with the grid. Otherwise, you cannot use your grid power and this power at the same time. So, or you can generate your own microgrid. So you don't have to depend on this grid supply. I mean, alone. You can take whatever power is generated, that can be your power station itself. So it can act as a microgrid, and that whatever power is generated, or that can be used to supply the energy to this charging station. Then the grid stabilization is again a big challenge, because utility or whatever service providers are there, electricity boards are there, they will not allow you to use the huge demand of or huge power. You cannot draw huge power at the same time. You cannot keep it idle also, because their penalties will be there if you are demanding or you are drawing more power from the grid for a shorter time. They will charge you more. So that stabilization purpose is also you need to think. So here you can utilize your battery, whatever energy is stored in that battery. So EMS is again a big role to play here. So EMS is energy management system. So how to utilize your available resources? Available resources, what priority you should give? Which power I should use? Whether I should use renewable power, whatever is available directly for the loading or for charging, or I should use that power to charge my batteries first, or use grid power whenever it is available. So all these algorithm or the programs we have to define, so that we can use the available power resources, whatever is free or whatever is cheaper, it should be given the most priority. Whatever is having costly affairs like grid power is more costlier, because renewable powers is freely available. You are generating it, and if you are not using it, it is getting wasted. So the priority should be given to the renewable power first. Then you can use remaining power in case of emergency. You can use the grid. So that is how you should think smartly to use your powers, and that is the role of EMS. So energy management system going forward will be the important or key factor for the power station, or you can say the charging stations. So I am repeatedly saying power station, but the going forward, the charging station itself is a power station for me, because it is generating power, utilizing high power from grid, and the loads, whatever are connected or whatever vehicles are there to get it charged. It is nothing but a power station kind of thing. So the other challenges like renewable energy credits. So if somebody is there nearby area which is having the power plant of renewable energy, you can take or you can purchase that power from him directly if your utility power is not available. So you can do the tie-up with that person also to get that power. You can reduce the carbon footprint by utilizing more renewable power for your charging stations. And then again, the policies and incentives also, time to time, you should get updates from the government as well. So what kind of facilities they are giving, what kind of incentives government are giving for this power station, because now going forward, power station will be a big challenge. And unless it is, because the cost of establishing or installing a big power station or charging station will be huge, because huge investments are required. If you are not only depending on the power from grid, you have to generate your own power as well. So you have to think on the government point of view also, what kind of incentives they are giving, so that whatever system we are designing, it should be optimized, cost effective. At the same time, it should not hamper the user also, because if you are charging the batteries, let's say at 5 rupees or 6 rupees uh, uh, per kilometer, if they are getting same charges, then nobody will purchase the EV. So whatever advantages we are seeing right now, maybe going forward it will get converted into disadvantage, because power shortage will be there. So to avoid all these things, government is also planning into that direction, and they are also encouraging to use the solar resources, generating more power stations, which is now the generation of power itself is increased, right? Now, these are again some challenges in integration point of view. So a high initial cost, I said, a space requirement will be there, grid upgradation is required. So, and the renewable intermittency is again will be there, because you need to mitigate whatever energy shortage or the storage is there, that you have to utilize very effectively to mitigate the shortages from the renewable energy. So all these are going to be the challenges in near future. So this also I just wanted to put up here points, so that the new breed or whatever new engineers are getting or coming to this market, or this whatever field is there, very exciting field, but coming up with a lot of challenges. We are not having that infrastructure at present, because we are slowly building it up. But going forward, maybe after 2 years, 3 years, 5 years on the line, all these requirements has to be there. Otherwise, we will not be able to sustain this whatever EV growth is there. So if you want to make greener India, or sustain this technology to be utilized in our daily life, then all these things has to be parallelly think of, and we should develop all these infrastructure also. Otherwise, if you don't have the charging station, then only manufacturing EV, nobody will purchase it, right? So now slowly people are now getting aware, infrastructure is getting developed. Now people, at least in metro cities, they started getting confidence that yes, I have the charging station outside. I don't have to depend on my home power, whatever power is available at the home. So this is the reason now EVs are getting expanded. So this infrastructure development is also parallelly has to be taken care. That's all from my end. Thank you all for staying with me.
Sir, my one question from you, sir. Good
Yeah,
evening, sir.
yeah, good
I am
evening.
Dr. Vivek from BRCM College of Engineering.
Yes, sir.
My question is that, sir, you have just told about the renewable energy for EV.
Right.
So, hydrogen production is also a renewable energy. Can I have use for the EV?
Yes, as I said, I already touched that topic into this EV. So we have the technology uh, now in India, at least these are getting developed now. The vehicles with charging, this hydrogen, whatever you are saying. So at present, we don't have the vehicle running on the hydrogen cell. So it is not yet commercialized in India, but as I said, Reliance has already made some vehicles in collaboration with Ashok Leyland. So once it is successfully tested, run in their plant, because the cost is more important here. So even if I develop, let's say, EV with hydrogen cell, running on hydrogen cell, and the cost of hydrogen itself is very costly. So to generate hydrogen of 1 kg, I have to spend almost 200 rupees now at present. So unless I have that technology to produce the hydrogen at a cheaper rate, that segment will not get that boost. So ultimately, the fuel cost should get reduced. Then only that technology can be taken up. Uh, so earlier, if you see this lithium-ion battery is also very costly. Now that cost has come down to half. That's the reason now EVs are very popular in India. If you think of, let's say, 3 years, 4 years before, the price of lithium ion battery was in the range of 200 rupees, $200 per kilowatt hour. Now that price has come down to 60 or $65 per kilowatt hour now. So you can think of the I mean, technology is not a problem here. So we have the technology, we can produce it. The challenge is the cost. Operating cost should be low. Then only people will purchase it. Otherwise, nobody is going to purchase just to have that vehicle. So I think yes, hydrogen is having a bright future. But the major challenge at present is the production cost of that hydrogen. So, as I
Thank you,
said,
sir. Thank you, sir.
yeah.
I got it.
Any other question? So we
Okay, sir. Thank
taken.
you for your nice session.
Thanks.
Sir, good evening, sir.
Yeah, good evening, Mr.
I have
Karthik.
one question, sir. The last slide, there is a one black diagram, sir. The first solar panel, then MPPT boost converter, and one DC bus, sir. So
Huh.
you use the MPPT boost converter. So what kind of control you use, sir, for either MPPT or voltage regulation purpose? Sir?
Yeah, so see, Mr. Karthik, I just draw a common, or you can say the infrastructure may be required in future if you have the renewable resources to be connected to a common DC source. Because if you have a common DC source, because here everything is new now. I have taken the charger also, which is DC to DC converter. If you, I'll present that again. One second. See, this was the slide you're referring,
Yes,
right?
yes, sir. Yes, sir.
So here, see, at present we are not using any of this right now. So this is the what you call what we are proposing now. So if we have the charger which is working on DC voltage itself, then having the DC source for the charging station will be easier, because you don't have to do more conversion when you have the power station or the charging station at your end, because all your chargers are connected directly to that DC common bus. So that DC common bus is like you can say the battery terminal, where you are taking all your loads, charging the batteries also. So all DC can be combined to single point. It is not that complicated when you have multiple AC sources combining together, because then net metering, other things are also coming into picture. So just to avoid all these net metering and other power consumption point of view, so if you connect all these PV or whatever this solar energy is there here, you have to make one common DC source, which is let's say if I want to explain, maybe 400 volt DC common bus I am designing. And from this 400 volt, let's say I am generating the power required to charge the vehicle also. So these chargers are there, which is taking power from this 400 volt DC and generating the power required by the vehicle in the range of 200 to 800. So it is having booster as well as the buck converter inside. This energy storage also I can make it equivalent to this 400 volt. So everything will work on 400 volt DC. So it will make my system very easy when I design the complete, you can say, charging station.
Okay, sir. Sir, actually, my question is, let us consider DC bus is 400 volt, sir. Okay. PVRA output voltage is 200 volt, sir. MPPT converter is we use, for example,
you cannot use different kind of PV array or battery storage or bidirectional maybe charger here. So
yes,
if you have decided to have a common bus, let's say of 400 volt DC,
yes, sir.
then
Yes,
your PV array should be of equivalent to that voltage. Your battery energy storage system should be of that voltage. Your charger should be of that voltage, which is taking power from 400 volt DC. So you need a charger, first of all, which works on 400 volt DC. So you have to start from your charger, right?
Okay, sir. I come to the point.
Bidirectional charger. So it is complete, you can say, a new system where we have just given the proposal, like if you make a system like this, then it will be less complicated compared to your AC system. So where you are generating solar power but connecting to AC, then you need an inverter there, right? Because you cannot simply integrate grid with your solar. You need some inverter also. So
Sir,
either you make, yeah.
Yes, sir, I correct, sir. But what my point is, let us consider a PVR is 200 volts, sir. For example, now MPPT boost converter is a 2-gain converter, sir. So 2-gain converter helps to boost the voltage 2 times, sir. For example, input is 200 volt, the output we get the 400 volt, sir. So then we match the DC bus voltage, sir. So my question is, sir, we use the MPPT boost converter. This boost converter helps to getting the maximum energy from the solar panel, sir. At the time it not consider the output voltage, sir. For example, let us consider duty cycle is 0.5 volt, sir. Sorry, 0.5, 50% duty cycle. At that time it provide 200 volt to 400 volt, sir. So if converter output is 400 volt, it's okay with the DC bus, sir. In case MPPT boost converter is duty cycle is 40%. In order to get them reach the maximum power, at the time, when the duty cycle is 40%, at the time voltage get down, sir. Maybe 350 volt. So now the voltage is lesser. How this time how the voltage is converter is connected with the DC bus? This is my question.
So okay, I understood now. So that's the reason I was telling you this complete exercise you have to design thoroughly. You cannot just select 200 because you have the 200 PV array available, right? So as I said, you have to start with the bidirectional charger first of all, because that charger you should have the charger first of all. So somebody has to manufacture or design the charger which works, let's say XYZ voltage. I'm not saying 400 is only the requirement. maybe 200 or 300, whatever voltage they are designing. So that charger should be available. Once this charger is available, then this DC bus design can be done. So you can select accordingly your MPPT booster, PV array cell here, maybe additional block you can add here, which is giving maybe the DC-DC converter here, which is giving the fixed voltage. So MPPT uses to give the maximum or draw the maximum power from PV array, right? But whatever voltage is generated by this MPPT can be given to the DC-DC converter again, and that will stabilize my this output voltage. So I will not give a raw voltage whatever is generated by the PV directly to this bus, because this bus should have all the whatever loads are connected and they should be at same voltage. So I cannot connect a PV array of 200 volt, battery of 400 volt, then this bidirectional converter which is working at 300 volts. So this complete design you have to do it. So it's not the ready-made available solution. We are just giving the solution where this can be connected. All your renewable can be connected, battery can be connected, on this charger can be connected to a single DC bus, where everything has to be designed by you, not it should be available also, right?
Okay. Thank you, sir.
Thanks for your question, Karthik.
Thanks.
Yeah, any other question? So we'll be meeting again on Friday for BMS.
Okay, when scheduled next?
Friday.
Let
I
me
think
check, sir. Let me check.
Friday 7:30, I think. You can communicate.
Friday 7:30. Okay. Good night, sir.
Good night. Good night. Thanks all of you.
Good
Thank
night,
you for
all the
joining.
participants. Tomorrow again 6 p.m. onwards we'll meet.
Thank you. You can post your questions if any after this also. I have already shared my email ID also, right? So
Okay.
thank you all.
Okay, sir.
Thank you.